Hey Team Electronics and Coding, welcome to your screencast. This morning, we are going to annotate some code together. So what I want you to do is go to our class on Tinkercad, open up the activity for homework intro to coding, or it might be for activity intro to coding. I'm not quite sure what I called it on our class. Open that up. And then I want you to make a copy, or say your button should say copy and tinker this activity. And I want you to open it up, copy and tinker it, and then open up the code and pull it way over so you can give yourself a nice wide place to write and take notes. Okay. We're going to be taking some pretty extensive notes here, and at the end of all of this, you're going to take a screenshot of what you've done. I want them to be your notes, not a screenshot of my notes. So at the top of mine, I'm going to write Kelsey notes, and at the top of yours, you should write your name. Okay, so we've talked about how to make a comment in your code. This is going to be a piece of text that you can write in your code that the computer's not going to read. It's 2 slashes. However, if you want to make, this doesn't work for multi-line. So if I wrote Kelsey notes and then I wrote down here, hi is now part of the code. If I try to run my code, I'm going to get an error because hi is not declared in the scope of my code. We'll talk about how to get rid of errors in this at the end of the screencast. Okay, but if I want a multi-line code, I can write slash asterisk. Now notice everything after this slash asterisk just changed color. I've commented it all out of my code. If I want to end my multi-line code, I can write asterisk slash. And now whatever is between these two slash asterisk and asterisk slash is not going to be part of the code. So I can write a multi-line comment here. Okay, quick reminder to you all that I'm going to start my simulation again. So I just get rid of those errors because it's annoying and stop it. Okay, we've talked about actuators and sensors. Actuators are electrical inputs, or actuators have electrical inputs. And they give you some sort of physical output. So an example in our sketch here of an actuator is our lights, our LEDs. They have an electrical input, they have a voltage applied and a current that's running through them from the Arduino, and the output that they give us is light, physical. Whenever you have actuators, you need to write to them in your code. Sensors are just the opposite. They have physical inputs and they provide electrical outputs. For example, our button is an example of a sensor. We press on it and that creates a complete circuit between ground or power here and ground here. And we're going to sense that complete circuit with this wire here that's connected to the Arduino. So we write to actuators from the Arduino, but we read sensors. Okay, so this is important. Write this down and know this. 2 other very important things that you're going to learn today. Basic coding structure. We're going to talk about variables and functions. Okay. A variable holds or stores a piece of info or data. They have a type. Different types can store different pieces of data or info. That's kind of vague, but hold on to that. Okay, when you create a variable, you decide the name. You create variables and you name them. So you want to give your variables names that make sense. That's a suggestion from me. In the context of your code. Okay, I'm going to leave that there for now, even though that's a little bit vague. We're going to talk more about variables upcoming. Functions are like a tiny program that is embedded within your larger program. Functions can be something that you write yourself. We're going to write our own functions later on in the term, but they can also be built into the programming language. So all the functions that we'll see in this code are already pre-built into C++, the coding language that we are working in. Okay, syntax of a function is important. You need to have the right letters, sequence of letters, and also the right cases, whether or not things are capitalized in order to call the function. I'm spelling things wrong as I'm typing. It's hard for me to type and talk at the same time. And when you write a function, it's called calling it. So the syntax is important. You need to get it right. Oops. Right to call the function. Okay, to call the function, there is a sequence of steps. 1, you write the name. It has to be the correct name or it won't work. 2, you add parentheses. Sometimes information goes within those parentheses, and that information is called arguments. So you add arguments inside the parentheses. Curly braces or brackets enclose the steps that the function executes. These are curly brackets. Some functions will have curly braces and some won't, so this is optional. Sometimes it's required, sometimes it's not, and you'll see when in a second. And then you end the function with a semicolon. Okay, so this is all a little bit vague, variables and functions, but hopefully with this information we can start to identify variables and functions within our code. Okay, let's start out here at the top of our code. We've created a variable, and we've named it button state. So this is, I'm going to start another multi-line code here. This is a variable, and so we have slash asterisk, and then we have asterisk slash. Okay, this is a variable that we've created. We've called it button state. We could call it Fred. We could call it Georgina. But what this variable is going to do for us is store the reading of the button. So it makes sense to call it button state. When you're writing your own code, when you create variables, it's a really good idea to give them some sort of a descriptive name as to what they do. If you write your code and you say, oh, I'm going to call this variable Georgina, maybe that makes sense to you, but someone else reading your code is going to really have a hard time figuring out what the variable Georgina is doing. So giving descriptive names to your variables is useful. Okay, the type of function that this is an integer. Oh, sorry, variable. It's an integer variable. This means that it can store whole numbers. So this type of variable can store the number 0 or 1 or 2 or 3 or 4, but it cannot store the variable 2.5, for example. That is not an integer, a whole number. Luckily, the button is a digital, digital, digital sensor. So, because it's digital, it can only have one of two states. Those states are either high or low, also known as 1 or 0. So digital, remember, is binary. It's zeros or ones, highs or low readings. This button is a variable or is a digital sensor, so it can only give us readings that are either high or low. So int is a really good variable to use for this type of reading that we're going to do on the button. Okay. So this is a global variable. That means anywhere we use it in our code, either in the setup or in the loop, we're going to recognize it because we've written it at the top of our code. Okay. Moving on. Now we get to the void setup. This is a function. It runs once at the start of the program, as you know. It has no arguments inside of the parentheses, but it does have curly braces that open and close it. So after we call this function, it's going to run these whatever's within the curly braces. So this is open, and this curly brace closes the setup. Okay. Below the setup, we have three functions that are all the same function. It's pin mode. Okay, so let's do another multi-line code here. Oops. Pin mode is a function that initializes our pins. It tells our Arduino if they are sensors or actuators. If they're outputs, they are actuators, and if they're inputs, they are sensors. We have to let our Arduino know if it's going to be writing to these things or if it's going to be reading these things. Okay, so the pin mode takes two arguments. Argument 1, so it's the first thing within the parentheses. Argument 1 is the pin number that you've attached to the Arduino. So this is attached to pin 3 over here. Let's put our code away for a second. So this is attached to pin 3 on the Arduino, and so that's the first argument. And then the second argument is input or output. Okay, notice the syntax here. Pin mode, the M is capitalized and everything else is lowercase. It has to be that way or you're going to get an error when you try to run your code. And then the output is all in caps. So the same is true for all of these pins. We have to provide arguments for these other pin mode functions that we're running here. So we've attached something to 4 and it's an output, then we've attached something to 2 and it's an input. And then we close the setup function with this curly brace. The pin modes don't have any commands that follow them, so they just end with a semicolon after they are done. Okay, now moving on to the loop. This is a function that loops around thousands and thousands of times in a second. Oops. So this is going to run over and over again. Here we have our curly brace that opens the loop. Here we have our curly brace that closes the loop. Okay, another multi-line code. Oh my gosh, this is a long screencast. Okay, this multi-line code is about the button state. Okay, digital read is a function. That reads the voltage on a pin. So digital read is what you use to read sensors. It takes one argument, and that is equal to the pin number that you want to read. Okay, so the argument is equal to the pin number. Digital read, when you're doing a digital read, it means it can read one of two states. Reads one of two states, and those states are high or low. Okay, so this function, digital read, is going to give us a reading of pin 2, and that is either going to be a high or low reading. That we set equal to the button state. So we store that information in our variable that we created at the top, button state. So this syntax, when we write button state equals digital read 2, essentially we say A equals B. This means set A equal to the value of B. Okay, moving on down to the next part of the code. We have an if statement. The if statement is written if button state equals high. This is actually very different than saying equals. And let's do another multi-line code here. And asterisk, and then asterisk slash. Okay, so A equals B means set A equal to the value of B. A equals B means check to see if the value of A equals the value of B. This up here, this is a statement. It means set A equal to the value of B. This is more like a question. You were checking to see if A is equal to the value of B. Now, if this statement or this question is true, the button state is high, then the function, then the conditions, so this is the condition, if the button state is high, then the function between the curly braces will run. But if this is false, if this is not true, the button state is not high, then the commands between these curly braces will not run. So if the condition is true, then the functions between the curly braces will run. Otherwise, they'll be skipped. Okay, so these are our curly braces right here that follow our if statement. and they only happen if this is true. Okay, so digital write, another multi-line comment here. Digital write, where we have slash, asterisk, and then we have asterisk slash. Digital write 3 high. Digital write is a function that sends a voltage to a pin. This is how we write to actuators. It sends a voltage. It takes 2 arguments. Argument 1 is the pin number. So here we're going to write 3, pin number 3, and then argument 2 is high or low. So we're writing 3 high here, and then right below it we're writing 4 low. So we could also write 3 1, and this would mean the same thing as high. Those 2 statements are equivalent. We could write 4 comma 0, and that would mean the same as 4 low. Okay, because it's digital write, it can only give 2 states. It's a digital function. Okay, as opposed to analog. We're going to learn about analog, read and write later on. Okay, we're getting to the end. Else will only run if the button state is not high. So if this condition is true, then what's between these 2 curly braces will run. Otherwise, these 2 functions will run. Okay, and then this is the curly brace that ends the loop, and the loop now starts over again. Okay, this was way too long. I'll stop.